Hi everyone, I want to talk about increasing the range of ambient backscattering communication sensors at indoor environments. Mm, the main goal of this is IoT devices, Internet of Things devices. Basically, as humans, we are trying to measure more and more things that are in our environment. And for example, we try to measure the temperature or the heart rate that a person has, or we can try to measure the amount of CO2 that we're gonna have in a cornfield, or probably we're gonna try to measure um, the the um, the rate of cars that are passing through an intersection. So this aim to measure more things bring us to the increasing of the number of devices. So the 4E Forum have projected the proliferation of the devices is gonna increase from 1,000 millions of units in 2018 to around 6,000 million of units in 2015. And this increasing of devices are gonna cause an increasing of the power consumption, are going to increase the number of batteries that these devices are going to require. So considering this, the again 4E Forum have estimated that the standby power consumption from these smart roads, smart street lighting, smart appliances, home automation, smart lighting is going to increase from around 15 terawatt hour to around 45 terawatt hour. So this brings us to the problem that we're gonna need more batteries, we're gonna need more energy, and this is economically and ambientally not sustainable. So our solution for this could be packet scattering communication, and the most common know about this one of this kind is the RFID communications. There's nothing more than a reader antenna who transmits some power to a tag or a sensor, and the sensor transmits back the information to the reader antenna. The problem is that the range between this antenna and this tag is not long enough, and in some cases, to get larger range, you need that this a tag or sensor has a battery. So we continue having the problem that we are gonna have to uh, require more and more batteries. So ideally, in order to increase the range, we have multiple options that we are considering as hypotheses. One is the use of a biostatic principle, in which one we are going to use two or more antennas to have a double received signal, and we can compare the signal between between those antennas and the information, and make a contrast that will allow us to increase the range. Other thing that is gonna solve our problem of battery use is that the use of ambient backscattering, in which one we're gonna be able, or tag is gonna harvest the energy from the ambient waves, that is a FM station. In our case, it's gonna be a Wi-Fi router for an indoor case, and this will allow that the tag collect the energy radiated from the router and it can send the information to the reader. That in this case, this SDR reader is going to be a biostatic antenna reader. Also, in order to increase the possibility of cut better signal and increase the range, we are thinking in using a phase array that would allow us to make a beamforming of antennas and make a directional arrival calculation, so we can improve our algorithm in the antennas to listen to the devices that we are. Here we have an example in which one these antennas could be modified by itself in order to reach different areas of polarization. Well, thank you so much and have a good day.